Let's do this. All right. Number one. What is the lens equation? So here's the lens equation. 1 over f equals 1 over dO plus 1 over di. Huh? Yeah. So 1 over f, 1 over dO plus 1 over di. And here's what they stand for. F is focal length. dO is object distance. And di is image distance. And I'm going to draw a picture of this here in a second to show you what they all look like, because it's kind of hard, like, if I just say focal length, it's kind of hard to visualize what that is. Same with object distance and image distance. Those are just kind of tricky to visualize, like what's actually going on here. Okay. Next one is number 11, the magnification equation. So that's m equals negative di over dO, which equals hi over ho. And to tell you what those things stand for as well, m is magnification. dO is, ho is object height. And hi is image height. Oh my gosh, spelling. So, here's the lens. Looks like this. It has two focal points, one in front, one in back, because the light can go either way. So it can either go through this way to a focal point or this way to a focal point, so that's why there's two. Okay, then I've got an object. Aha. Then I've got an object, and that object makes light, and that light creates an image, like this. So here's what all these things are. So this right here, that distance between the mirror and that focal point is the focal length f. This distance from the object to the lens is dO. This distance from the lens to the image is di. The size of that arrow is ho, and the size of this other one is hi. So that's what all the things are. Okay? So just so you can visualize them and see what's going on. Okay? Just so you can see what's going on there. Okay? So you got a focal point. That's the focal length, how far away it is from the lens. The object's distance away is dO. The image's distance away is di. The height of the object is ho, and the height of the image is hi. Okay? All right, so what do the signs and all this stuff mean? So if you have a sign of magnification that's positive, that means the image is right side up, and that means it is a virtual image. Now, you might be saying to yourself, Mr. B, I remember we talked about those, but it's been a weekend. I don't remember anything anymore. So real images are where the light actually intersects at a real place in space. And virtual images are where light appears to intersect, but it can't actually reach there. So here is a real image. What I drew is a real image. The light actually focuses at a real place in space. A virtual image is like this. It looks like it comes from over here, but it doesn't actually come over there. It came from over here. Okay? So if you have a right side image, it is always virtual, which means if you have a negative magnification, it is upside down. And that is real. It's a real image, like Pinocchio. Okay? It is real. Pinocchio is a real boy at the end of the thing. He's a real boy at the end of the thing. Pinocchio is so creepy. It's super creepy. All right, let me clarify this one. So value of m, put an absolute value symbol on the either side of m, because I don't care if m is positive or negative. I'm just looking for the value number of m. So if m is a negative 3, just treat it like 3. If m is a positive 7, just treat it like 7. But here's what it means. If magnification is greater than 1, it means that the image is larger than the object. And if you get a magnification that's less than 1, it means the image is smaller than the object. Okay? So here's what I mean by that. Let's say you got a magnification of 10. That means that the image is 10 times larger than the object. 10 times larger than the object. If you have a magnification of negative 10, it's still 10 times larger than the object. Okay? So the negative doesn't affect the value. Now, if you got a magnification of 1/2, that means it's half the size of the object. Half the size of the object. Okay? So anything less than 1 is smaller than the object. Anything more than 1 is larger than the object. Okay? So that's what's going on there. All right. What's the sign convention for focal length for the two types of lenses? Convex and concave. So converging and diverging. So converging lenses, they have positive focal lengths. And diverging lenses have negative focal lengths. You'll see that in the examples that we do. That's it. Use positive for converging, negative for diverging. Okay, so here we go. Real quick, we're going to jump to the back page. Here's